Okay, so this lesson is on section 6.6, Permutations and Combinations, but we also study something called the fundamental counting principle. So go ahead and highlight that. We have already actually used the fundamental counting principle. I just kind of snuck it into your lessons earlier in chapter 6. So I promise you've done it. We've talked about tree diagrams before. So when you're creating a tree diagram, you have different events. So in this tree diagram, you have two options for dessert. You have cake or ice cream. So you've got two options, right? And then you have another event, which gives you 3 additional options. But it's 3 per whatever you had in the first event. So it's going to be 2 times 3 is going to give you a total of 6 outcomes. So we've been using the principle the whole time. The difference between what we've been doing and what you played on the Kahoot and today is that today these examples are a lot more complicated. That doesn't mean they're difficult. It just means that they're a little bit more complicated. Okay, so let's get to it. We have a door that requires a 3-digit code to be opened. None of the digits in the code are the same. That's a really important detail when you're figuring out codes. It says, what is the probability that you guess the code on the first try? Well, before you find the probability of anything, you need to figure out how many total possibilities, aka outcomes, we can have with a 3-digit code. So what I'm going to do is I'm going to put 1, 2, 3 spaces. So each space represents 1 digit in your code. So this is the first digit, this is the second digit, and this is the third digit. Okay, so what you have to do is you got to figure out how many different digits do I have to pick from. And a lot of people want to say 9, but they're forgetting about 0. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That is a total of 10 possibilities. If you were going to make a tree diagram, and you are not going to do this, because I will show you why you're not going to do this. Please do not copy down this tree diagram. You're going to have a 0, a 1, a 2, 3, 4, 5, Go all the way up to 9. Those are all of the possible numbers you can pick for that first digit in your code. Y'all with me? Okay. Second, can I repeat a number? I'm not able to repeat a number, so what happens to my sample space? It goes from 10 to what? 9. Only have 9 numbers to pick from for that second number. So if I were to create a tree diagram, I would have to branch every single one of these numbers out 9 times. Okay, now do you see why I don't want to make a tree diagram for a 3-digit code? I don't want to do this, okay? So third number, how many do I have left over? I only have 8 left over, so each one of those would have to branch 1, 2, 3, 4, 5, 6, 7, 8 times. Do you see how obnoxious that tree diagram is going to be? So we are not going to create a tree diagram for a lot of these situations, okay? So I've got 10 times 9 times 8, which is going to be equal to 720. That means that you can have a possible 720 different codes, assuming that your digits do not repeat, okay? Now, the second part of the question is asking about probability. So how many correct codes are there? There's only one correct code, right? Just one. So you have 1 out of a total of 720 total codes. So your probability would be 1 out of 720. So I'm sure that some of you have seen this Florida license plate at some point. Specifically, this license plate has 1, 2, 3, 4 letters. And then it has 2 numbers. Now, if you read the question, it does say that it will not allow you to use all of the letters. It has an exception. It won't let you to use the letter O, okay? But I have 4 letters. I absolutely do not want to make a tree diagram, so I'm just going to use spaces. So these are going to be my 4 letters. And then these are going to be my 2 numbers. Now, this one's different. Am I allowed to actually repeat anything in here? It didn't say anything about not having repeating, correct? So if it doesn't say anything about not having repeating, then it's okay. How many letters are in the alphabet? We have 26 letters in the alphabet, but can I use all 26? Okay, so I can't use all letters, so I'm going to have 25 different letters. If I can repeat, then that means that I'm going to have 25 options for the first 4 letters. So if you're going to do a tree diagram, you'd have 25 in the first column, and then you'd have to branch 25 for each one of those first 25, and so on and so forth. So obnoxious. Numbers. I have 10 numbers to choose from. I can repeat, so I'm not losing any numbers for the second one, so it'll be 10. If you take that and you type it in your calculator, you get 39,062,500 different license plates using that particular situation. So what's the probability that you're going to get that one very specific plate? It's just going to be one out of all of the different possibilities. Okay, now that we've done a couple of examples, I want you to read this one on your own. I want you to try it. Go ahead and pause the video, work it out, and see if you get the right answer. Okay, let me show you the whole question in case you don't have notes with you. Go. Okay, so what you got to do is you've got 4 spaces, 1, 2, 3, 4. You are not allowed to repeat. So you've got 10 digits for the first choice, and then you're going to have one less, and then one less. So the question is, what's the probability of guessing that security code on the first try? So if you multiply all of these together, you get 5,040. The probability, though, would be that one correct code out of 5,040 possibilities. Okay, so that was goal number 1, for you to use that fundamental counting principle to figure out the number of outcomes and to answer probability questions. Goals number 2 and 3. You need to be able to make calculations using permutations and combinations. So if you've got a highlighter, what I would do is I would highlight order is important and order is not important. Now, when I say order, I am not referring to independent versus dependent. That's not what I'm saying. What I'm saying is, after you've picked everything that you're picking, does the order matter in which you pick it? Okay? So, for instance, let's say that you are in a competition of some sort. Okay? How many different ways can we have first place, second place, and third place? Do you think the order matters if you're in first place, second place, or third place? I think it does matter, because most people want to be first place rather than second or third, okay? So if you are trying to rearrange books on a shelf, arrange is a word that means permutation. I know y'all love your seating charts. So when I do a seating chart, does the order matter how you are randomly selected? Absolutely, because it depends on what seat that you're in, okay? Now, a combination would just be just a group of people, and it doesn't matter how they're selected, okay? So if I wanted to pick like maybe 4 toppings on a pizza out of like a selection of 20 toppings, as long as you have all of those 4 in that order, it doesn't matter. It doesn't matter which one you put in the computer first. It's just they're all there. So group would be like a combination, okay? All right, so I'm going to show you how to type these in on your calculator. We're going to practice figuring out whether something's a permutation or a combination, but first we're going to practice on our calculators, okay? So our first example of a permutation says, how many ways can you arrange? Now, your keyword right here is arrange. If you're going to arrange something, the order matters. There's no question about it. So this is clearly a permutation. We are rearranging all of the letters in July. So you're going to ask yourself, how many total letters do I have in July? I have 4. So you're going to put a little bitty 4 right there. Since it's a permutation, you're going to do a capital P, and then you're going to pick from those 4. How many of those 4 are you going to rearrange? We're rearranging all of them. So we're going to rearrange all 4. So if you look on your notes right here, it's got kind of like the generic notation. So N is going to be your total, and then R is what you're going to actually choose or pick from. Wait, I got to spell choose right. There we go. Okay, so on our calculator, it's a little bit awkward, which is why I need you to practice. So 4, pick 4. Let me show you the calculator. Make this smaller. Okay, so on your calculator, you're going to hit 4, which is your total. You have to put your total in first. Now, do you see the probability button on your calculator? It's PRB, it's at the top. So if you hit PRB, it gives you a choice between a permutation and a combination. So if it's a permutation, you're going to hit 1. So you're going to do 4 and then permutation, and you're picking 4 and then hit enter. So you should have 24. So there are 24 different ways for you to arrange the letters in July. Combinations. So this is where your order doesn't matter. The reason why the order doesn't matter here is because you have groups of 3 people, and within the group, there's no specific job or anything, so you're just part of the group and that's it, okay? So I've got a total of 10 people in this group. The order does not matter, so I'm going to use C for combination, and I am picking 3 out of those 10. So if you grab your calculator, you're going to type in the number 10 first. Find probability, and you're going to select 2 for combination, and you're going to pick 3 out of those 10, which is 120. And if you ever forget, you can kind of look right there. Those are all your keystrokes on your calculator and how to do it. And yes, you can type it into Desmos, but I'm going to be honest with you. I think it's a lot more annoying to use Desmos because you either have to remember what to type in or you have to find a very specific button. So you have to kind of like search for it. So highly suggest to use your calculator. Okay, so here's where we're going to practice figuring out whether something is a permutation or a combination. So number 1, it says you're listening to music. You have time to listen to 3 songs from your playlist of 16 songs. How many groups of 3 songs are possible? Is that a combination or a permutation? So pause the video, think about it, see if you're right. Okay, so this is a combination because of the word group. You have a group of 3 songs, then that song's going to be in that group, and that's it. There's nothing specific about being chosen first, second, or third. So this is a combination. We're going to put C right there. Okay, question number 2. I'm not even going to ask you on that one because it literally says the word combination. Y'all see it? It says how many possible combinations are there. So 2 is a combination. Super easy. Number 3, 10 horses run in a race. How many different ways can the horses finish first, second, or third? Assume that there are no ties. Does the order matter? Yes or no? So yes, the order matters. That's a permutation. Number 4, consider the letters in the word March. How many different ways can you arrange them? Is that a permutation or a combination? Okay, so this one right here has a clue, arrangement. Anytime you arrange anything, the order absolutely matters. So this is going to be permutation. Okay, number 5 is tricky. Number 5 is tricky. How many different 5-card hands can you have from a standard deck of 52 cards? All right, so if you're dealt a 5-card hand, it doesn't matter which one you were handed first. You take all 5 of those cards, and it's just a group of cards. And you make a play based on those 5 cards. It has nothing to do with what you were handed first. So this is a combination. And then the last one, if you've got 12 floats in a parade, and you're trying to figure out how many ways that 2 of them can be first and second. So first and second would be a permutation because the order matters. All right, so what we're going to do is we're going to actually figure out the numerical answer to your question. So on number 1, it says that we're doing a combination. So how many total songs did I have in this playlist? I had 16. How many am I choosing? I am going to choose 3. Now I'll put a C there because the order didn't matter. So go ahead and practice right now. So this is the time that you need to use your calculator and you need to practice on the calculator because I am not going to tell you how to use your technology on the test. You have to know how to use the technology. So practice it right now. Okay, so on the calculator, if you put that in there, you wind up with 560 outcomes. Good. Okay, question number 2. We are choosing 2 out of a total of 4. So put your total first. 4 letters. Choose 2. And you should wind up with 6. So go ahead and type it in your calculator, practice it, and make sure that you get 6. All right, question 3. We've got 10 horses, and we are trying to figure out first, second, and third place. So this is a permutation, and we're picking 3 for first, second, and third place. All right, next up, we are arranging the letters in the word March. So I have 1, 2, 3, 4. I have 5 letters. And if I'm arranging something, the order matters, and I have to arrange all 5. So it'll be 5, pick 5. And then the next part is asking 3 of the letters. So I'm going to do 5, but then I'm going to only pick 3 that time. So go ahead and type those in your calculator, see what you get. I have 120 for this first one, and you should have 60 for the second one. All right, last 2 on the top section. It says, how many different 5-card hands can you have from a total of 52 cards? So the 5 cards that you have just kind of go into a group. So I'm going to do 52, and I'm going to choose 5. Now this number is going to be really big. It's because you have just a huge sample space to pick from. And just kind of double check and make sure that your answer is what I have on the screen. Okay, last one on the top. We've got 12 floats in a parade. We want to figure out how many different ways we can arrange it first and second place. So I'm going to pick 2 from those 12. So the P is when the order matters, and the C for combination is when your order doesn't matter. And you should wind up with 132. So none of those involved probability. Those are just you practicing combinations and permutations. Okay, so in this section, what I did is I just kind of mixed everything up. So some of them are fundamental counting principle from the very beginning. Some of them are permutations. Some of them are combinations. So I'm going to go ahead and do the first one with you, but I want you to read all the rest of them, and I want you to try to vote whether you think they're permutations or combinations. Okay, first one is neither a permutation or combination because you're trying to figure out how many different possibilities that we have. So we got a 3-digit code, so you got 3 spaces. It can repeat. So that means you got 10 digits on the first one, you got 10 digits on the second one, and you got 10 digits on that third one. If you multiply them all together, you get 1,000. Okay, so you got 1,000 different possibilities. The question, though, asks you what is the probability of you getting that first code correct. So you only have that one perfect code, right? So it's going to be 1 out of 1,000. Okay. Take about 2 minutes, and I want you to try to figure out, just write P or C next to these other ones and see if you can figure out if they're a combination or a permutation. And if you're wrong, you can just mark it out and change it. So let's talk about why each of these are what they are. So in question number 2, I know it's a permutation because of this word arrange. If you see the word arrange, it's automatically going to be a permutation. No question. Okay? Question number 3, this one's a little bit, this is difficult, but the order does matter in which you were interviewed. So that's why it is a permutation. So if you don't understand the order matters, now you do. Now you know, okay? So if it's about, scheduling an interview time, it does matter. Number 4, you are choosing 3 books from a list. It says the word combination. So it kind of gives you a clue. It's definitely going to be a combination. And then number 5, this one, I know you want to get picked, but that's not what the question's asking. It's asking, does it matter who is called first or second? You've got 2 customers, both customers are going to get the same prize. They're both going to get pizza. So it does not matter which one's called first. And the last one, hold up, I wrote the wrong one. That should be a combination. I'm sorry. 6 is a combination because all you're trying to do is you're trying to put it at the top of the page. It doesn't matter the order that they are in as long as it's at the top. So that's a combination. So let me go ahead and finish all of these using the numbers. Okay, question number 2. I've got 6 letters, and I'm picking 6, and then that should give you 720. Now, if I'm going too fast on the video, just pause it, practice it, type it in your calculator, and just make sure it's working out. Okay, B is 6, but this time we're only picking 3 out of the 6 letters, and then that's going to give you 120 on your calculator. Okay, question 3, we're doing 2 out of 9, so I'm going to start with 9, and I'm picking 2. And that gives you 72 possibilities. Combination's going to be 7, but I'm going to choose 3 of those books. And the order doesn't matter, so that'll be 35. Okay, 2 lucky people get free pizzas, and it's out of 30 people. So it's out of a group of 30, and then we're going to choose 2 of those 30. There's 435 different ways that you can be chosen, so the probability of you winning is going to be 1 out of 435, you and your friend. Okay, and the last one's going to be 20, choose 2. Which is 190, and the probability would be 1 out of 190 possibilities. And just let me know if you have any questions. Please do your homework because you need practice on the permutations and combinations.